Hello again. This is our tutorial on correlation with scatter plots. Basically, what a scatter plot is, you've got three good examples here on the screen, is a graph with just a bunch of points graphed as dots on the screen. But depending upon what those represent, they're usually for real world situations, we say that there's a correlation. So we're going to look at the three basic types of correlation, meaning how are these points related to each other, or what do they tell us? And then we're actually going to go to real world graphs of them so that we can sort of get even more information. The first part is just the types of correlation. So I'm going to look at the first one, which is a positive correlation. I'm going to go ahead and highlight that in blue. And as I'm looking at this graph, I'm noticing that the domain, which is the x values on this x-axis, is increasing. So I'm going to put that the arrow is going up. The range, which is the y values, which is this axis, is also increasing. When they're both going in the same direction, you'll notice that the dots definitely have what we call an upward trend. They're definitely moving up. They're not all in a straight line, but they're definitely moving in an upward trend. So when we see this upward trend, we say that the points have a positive correlation. I'm going to scroll down here a little bit. We're going to look at the next example, which is a negative correlation. Now, if we're looking at this negative correlation, once again, we're going to talk about the domain. The domain is still increasing. It's still going up, but the range, the y, is actually decreasing. It's going to go down, and because they're going in opposite directions, the dots, the points, have a definite downward trend. Once again, they're not all in a straight line, but they definitely look like from left to right, they're going down. So when we see this downward trend, we say that the points have a negative correlation. Now, the last one that I'm going to look at over here is one where there is no correlation, because the dots are just scattered everywhere. You really can't tell what they're doing. The x values are increasing, the domain is increasing, but you can't tell what the range is doing, and the dots are just spread out. You can't see that it's going up, going down. They're just all over the place. And when you can't really tell what's happening, we say that they have no correlation. Basically, there's no relationship between them. Now, it's important just to remember that when we're looking at a graph, we keep talking about the domain. The domain is the independent variable, which is on the horizontal, the x-axis, the one that's going side to side, left to right. When we talk about the range, we're talking about the dependent variable that's on the vertical y-axis, which is the one that's going straight up and down. The last little thing we're going to look at is what I call the correlation visual aid. We're going to talk about the strength and the direction of these different correlations. If we look at this first one, we say that this is a perfect positive correlation because literally all the dots are perfectly lined up in a straight line. This is also linear because they're all perfectly in a straight line. Whereas if we look at this next one, it's still positive. I mean, it's going up like the previous one. Okay, but they're not all in a nice straight line, but they're in what we call a pretty tight band. If I highlight the area where the dots are, they're all in this area. That's a pretty tight little band of dots, and they're still going up, but they're all kind of close together. Now compare that to the next one, the weak positive. If I sort of draw around them, this is a much wider band. So it's kind of weak. It still looks like it's going up, but it's a much wider band. And in fact, some people would come back and say, well, you know what? This dot over here, I'm going to highlight that by taking it out, is what we call an outlier, and that it doesn't really seem like it fits in with the rest of the dots. And these two dots here also are outliers. They don't even fit in. Most of the dots appear to be in that area. But that's why this is a weak band, Because if we look at it, most of the dots are here, but then have these extra outliers which spread it out even farther. Now, as far as the negative correlations, once again, we have this perfect negative correlation where the dots are all in a nice straight perfect line going down. The next group is again going down, but they are in a tight little group. So we call that a strong negative correlation. And then just like before, we have what happens if they spread out. If they spread out, they still look like they're going down, most of them, but it's just a wider band of dots. Notice I left these two out because they're kind of what we call the outliers again. And then in this last group, I can't really even draw a band around them. I can't tell where the top is or the bottom is, if it's going up or down, because it literally has no correlation. It's like they're all outliers. They just don't seem to have any definite relationship.